So without further ado, the first speaker is Ralf Weber from Akamai, and his talk is on ECH from a DNS data perspective.
Hello, so I think I renamed the talk a bit when I did my slides, but it's, it's the HTTPS record that I'm talking about. And now this clicker does not, oh, it does work. Okay, so quick, what I'm going to talk about why I did it, then how I got the data, what I did with the data, and then the actual data findings and questions. So why did I do this? Well, I mean, the HTTPS or SVCB record type is really the first record type in decades, the new records type that we had that gained some traction in real-world deployment. Because a lot of the other stuff that we happened to do there, really wasn't visible in data in a huge chunk. The HTTPS and SVCB record is, and it's also a very versatile record. It can support lots of different stuff. You can do encrypted client hello, you can do CNAME at the epochs if Chrome would support it, and I'm sort of one of the co-authors of one of the DELEC drafts, and I think the record is so generic and so nice that we can actually do more stuff with it. And I want to look out, well, holistically, if you look as wide as you can, what is the support out there? And I talked about this record before. This is a slide from the OARC 34 talk that when Apple introduced the HTTPS lookups pretty much in their operating systems, this is how the ramp up looked there. So there's a lot of data out there. I initially, because I'm a resolver guy, wanted to, I look at all the resolver data that we at Akamai had, which is a lot. And I said, well, that might be a good idea to do that. But then I discovered that the actual data I was interested in was in the answer. And if you do tens of millions of queries per second over a global platform, looking at the answers is not easy because we normally don't store that. And so I wanted to set up a pipeline, but I just ran out of time, which is a common theme today. So I said, well, I need to look somewhere else. I've just looked at one day of our data for a specific service and got 344 million names out of that. And I really looked at anything that was queried there, just names. And then I looked at the ICANN centralized zone data service. I always need to look that up. And you can get access there, and for research you can download the data, and it's useful data. And we use it also in our resolver testing a lot, so I have that access to that data, and I just use it also. And then I come across something called the Merkle map, and these guys, I think, use certificate transparency logs and kind of store them, and the data is also accessible for researchers. You can download it there. It's 40 gigabytes file, something like that. And from that, I got another 734 million. So if you count that together, it would be 1.3 billion, but no, it's not. Because I'm only interested in positive answers. Something that, and mostly positive answers that lead to something the SSD records does, which means a website or something. So it's usually I want to have an A or a quad A answer, and I'm really not interested in X domain or no data. But I want to kind of get more data, because more data is always better than less data. So I kind of took all the data I had and just see if there's no WW at the front, just prepend and see if you can resolve that. And so with that, I looked for pretty much lots of the FQDNs and tried to get A, quad A, and HTTPS records. And if I had HTTPS record, I examined that further. Now, we'll come to that later also. So the data that I will show is not about queries, because normally I mostly talk about queries. But this is really about the number of FQDNs and what kind of properties they have. So when you look at the HTTPS queries, we've seen a lot of increase in the last year, because Chrome now does it. The specific I have there is from this one deployment that we have that is for more business customers. And it used to be that we have 5 to 10% of queries there that were HTTPS. Now it's 13 over that day that I tried it. But that means that only 5.49% of these domains that were queried there actually have the record. So it means that each record must have been queried more than once, or the distribution of records is more. So the numbers you'll see don't say anything about the popularity, but it is a really a wide look on what exists out there. And with that, I got roughly about 1 billion of FQDNs that respond to an A query. And from that, I mean, Quad A or V6, 22%, well, could be better, but still. But HTTPS being a really, really new record is something like 7%, and I think that's kind of a lot when you think how young the record type is. And of course, the thing in DNS always is, you do stuff at one point in time, and then you do it at another point in time, and the result is different. So I had around 77 million records that were answering with HTTPS to my first query. And then a couple of days later, I ran the actual gathering queries, and well, there were only 75 million. I mean, that's just the nature of DNS. It's very dynamic. But it's still, I memean, it was overall, for the latest stuff, still something like 7.26%. I don't think I have the percentage number. No, 7.25%. What also was, I think for me at least, a good thing that if you have an HTTPS record, there's a high chance that you also are using V6. So modern stuff seems to kind of come together, which is good, and that's also shown there. So let's talk about what is an HTTPS response or SVCP response. And when you see the first lines, there are just some stuff I made up, and this only tells you that I'm interested in 80s hard rock music, but also, I mean, it is kind of like it's a very variable record, so each answer can have more than one record if the kind of author of the data wants it. And you see there's lots of difference in there, like different targets, different parameters, I mean, we don't have different priorities in that examples, but you can have different priorities. And the really, really nice thing about SVCP is that it can have parameters, and the parameters are extensible. And the current stuff that we have is ALPN, IPv4 hint, ECH, DOE path, which I think we shouldn't see much in the HTTPS, but which we see in the SVCP for the upgrade. And it's like DNS. One of the good things about extending DNS is you can pretty much come up records, and you can even do new records without actually understanding them, because we have something like a generic record type in DNS, and we also have that for SVCP. So that's very, very good. But when you look at the numbers here, it's, how do you say, very uniform. So most of the domains out there only have one record. And if you have two records, your priorities are 1 and 2, pretty much. And that's all. And again, the 30,355 that are not reachable by Chrome, that's bad. Targets. So where are they pointing to? And the most common point is really dot. That means you just kind of, the owner name that is the input to the question will be used as a target name for further lookups. And the really other, I mean, there were a different kind of, different target names that I think, didn't stood out. The stuff that stood out was Meta, which kind of seems to use that a lot with different targets. And also a considerable number of FQDNs. And you see, 0.1 to 2% is a small number, a very small number. I guess if I would look at what the 0.1 to 2% actually do in resolution, it would be a much different number. So that's why I said it's kind of like it's the wide view, it doesn't tell you anything about popularity. And I looked at AWS and Azure and said, oh, cool, also they are using it. And I looked into it further. Nope, it's only CNAMEs to CDN, which were where they're used. So let's look at the parameters. Again, ALPN and IPv4 hint are the most common, and all these results look a bit like, I don't know, former Soviet Union voting results. It's really very, very uniform. I mean, ALPN is 99.5%, IPv4 hint is the same, and then IPv6 hint is 96%. And I mean, ECH is not as common, but it's still 85%, so that's good. And the other is really noise, I mean, port. And the 32768, if people might remember the adaptive DNS draft that Apple supplied to the IETF a couple of years ago, looks like they've implemented that because it was only Apple domains, but it's not really used otherwise outside there. So let's look at what people are connecting to, because the ALPN is what people in the web then use to connect. And again, it's very uniform. Most people do H3 followed by H2, so quick, and then HTTP2. There are a bunch of that only do H2, and the rest, again, is pretty much noise again. And ECH, because that's the, that actually triggered sort of that talk that then kind of got in a different direction when I looked at the data. There are sort of 65 million domains, but there are only 151 keys. Now, that itself isn't a problem because at least the people in our company that deal with ECH told me that that's normal. You should have a key per deployment. So there's no need to have a key per domain. That would be overkill for ECH. At least that's what I'm told, and I believe that. And so that's not too common. But the first three keys, I looked at kind of the domains that they have and what the IPv4 and 6 hints after. They all belong to the same provider. So it's pretty much only one provider doing ECH from what we see here. And let's look at the kind of hints of these records, because they will show you, hints will show you where stuff actually points to. And when you have an IP address, you can look up which IAS is using it. And that should tell you pretty much which provider is using it. And, well, I did that. There were 425 different ASs. The first two, again, belong to the same provider. I mean, some providers have more than one AS, first two same provider, so looks like it's that one provider really is into HTTPS. So the summary is HTTPS is deployed. I think it's still a success story. I still wish that browsers had more supports or more consistent support for it. I didn't do a lot of this here, but I think the next talk will get into that a bit more into detail, because I'm just frustrated by it. And ECH is being deployed, but it's also dominated by a single provider. And well, I mean, I think there is, which again, because I didn't cover the popularity aspect of it here, I think the deployment is not as bleak as I make it, only by one provider. But I mean, we need to look into more data to really get a hold of that. So this probably will be continued. And with that, there are questions.
Since okay, I have to go up here. So I guess I could be on camera. So because I didn't take up my full 5 minutes, we have about 8 minutes for questions. So we do have plenty of time if people have questions for Ralf.
Hi, Ralf. Puneet from Google. So I want to take you up on your qualification of this as a success, in the sense that if only one operator is the one we are seeing, are you also then seeing hints of others starting to show up? I know you said you have only looked at the query volume or the answer volume, not the query volume, just the amount of data which is there.
Yeah.
But do you have some additional context or data to share about that this is getting deployed by others or increasing in deployment?
Unfortunately, no. I mean, I know that a couple of others are also deploying it and using it. I mean, Apple is one example. I would love to look more into it, but again, time and getting the stuff set up just ran out.
Okay, thank you.
Hi, Terry Bernstein, IBM, NS1. I just want to make an observation about this, because I talk to a lot of customers about HTTPS record type, and my observation is most people have no idea what it is, so it feels like there should be some public, I don't know, some campaign to inform the community. I tell a lot of big web properties, internet application properties, hey, you should look at this new record type, it could have some value to your delivery. People are like, we have no idea what it is. So I try and educate them, show them things. But I think that, to me, is what I see as why it hasn't been adopted as widely. Just people don't know about it and don't know the value.
Yeah, thanks, we'll try.
Yeah, I was going to say something kind of similar, which is the question I asked in the Mattermost. For a long time, we were trying to get people to stop using the non-standard alias is because it made it hard to be interoperable with multiple providers, and not everybody was sure they needed multiple providers. So we've had a lot of hacks to deal with that. And because it's called the HTTPS record, people don't understand it actually provides you with this feature, which is very helpful. So one possibility is that we do a little bit of work because it's fairly early days, and we help people to understand that. Do you think that's right, or that we are waiting for something else, or there's some other way to do this? At PCH, we're in the midst of several of these types of engineering conundrums, and it seems like it's part of our work. It's not research, but it's part of engineering.
I think it's definitely worth spending time educating and telling people about it, especially about the kind of apex at the alias, which is kind of like a DNS use case. Only DNS people care about, I feel. But the problem is, someone needs to fly to Mountain View and tell Google to implement that in Chrome. Because, I mean, if it's not in Chrome, which is something like 70% of the browsers, I mean, I don't care. I use Safari. For me, it works fine. But there are other people out there.
Maybe surround some people here in the social.
Good try.
Hi, Ben Schwartz, Meta. I'm glad somebody noticed those HTTPS records.
Thank you.
I wanted to comment, as I think you're probably aware, counting the number of ECH records, it highlights Cloudflare's deployment due to an interesting detail of how these deployments are structured. That Cloudflare's architecture generally essentially carbon copies the DNS record across each customer zone, and so that results in millions of copies of this record containing the ECH keys. Whereas for other hosting providers, that record might be living at a CNAME target, and there might be millions of domains that are aliased by CNAME to this single record. So I think in your count, that would show up as one record on.
Well, I mean, no, because if there is a CNAME, I mean, that's how I did this. If there was a CNAME that in the end kind of reached an HTTPS record, I've counted that in.
Oh, that's it. Okay. That's interesting.
Yeah.
Thanks.
So.